Hello boys and girls, I am the Guide Knight and welcome to part 10 of my Godot platformer tutorial. Last time we added the robot's ability to act, basically moving around and not really interacting with the environment but just moving around randomly and staying still. So as usual, as it has become a little bit of a custom I guess in the last episodes, we made some small or rather weird mistakes. For instance, I killed the robot, the kunai disappeared, but the robot is not dying. And why is that? Let's enable the collision shapes. Make from debug visible collision shapes, make the collision shapes visible and see what is happening to fix this bug. Okay. So the robot is running, it's stuck in the running animation, and when I hit it, basically the shape moves down. So I see like two issues here. One of them is in the kill state, we are continuing to kill the robot even after the robot is dead. So let's add an if statement. If state equals dead, then return. We don't want to kill it more than once, right? So this should fix the problem with moving the collision shapes down when we hit it multiple times, but it doesn't fix the problem of not playing the animation. This can be fixed also relatively easy. This happens because we animate the dead state, but we basically we kill the robot. Okay, we kill the robot, and then we set the state to dead. And then in the next iteration, it checks, okay, is the state dead? Then I return, and it does not go to this animation, animated sprite play dead. So we can either call animate here, and this will play it once, or we can simply play it directly after. Maybe we can just play it once after the kill. So let me try this one. Yep. And I should still be able to move, but my kunais are passing through. Maybe I can also disable the collision shape, but if I disable the collision shape, the robot will fall down entirely out of the... Well, it will fall down endlessly because it does not interact with the pipes in any way. So maybe I can just quickly try to go to my kunai. I'm not sure if that actually is going to work, but let me try. If I move my kunai to layer 2, maybe... Yep. So basically, the same solution we did for the player in the last episode. We moved our kunai, the collision, like physics body to the collision, we move it to layer 2. So it does not check with, well, so that it is not detected by the robot. Like the robot is also on layer 2 as well, and then it checks for layer 1 collisions, and this is layer 2 and checks for layer 1 collisions. So basically it becomes something like this is the robot, and inversed. This is like the layer for the robot, this is the mask for the robot. Maybe that makes no sense for you, but basically the solution is to move it to layer 2. So the inverse check from the robot to the kunai is not matching, and therefore there is no collision. Okay, so now let's actually start adding new stuff, right? We want to add, like we have this simple level generator, and we would like to have a similar thing called, I don't know, enemy generator or something. So let's go ahead and add a new scene. And this is going to use a simple, maybe Node2D, because we can probably move it around. I don't know. Let's try with Node2D and see how it works. Like enemy generator. We just call it enemy generator. And we can save it with Control S under enemy. And this is going to be enemy generated TSCN. And we're going to add a script to it. All right? We're going to create a script. So what does it need actually, this thing? First of all, it needs to have a constant, the robot, right? We need to have the robot class so that we can initialize it. So let's go ahead and get the robot class. We can even call it robot underscore class, and we're gonna use preload, the preload function as we have used before, and just drag and drop the robot scene here. So now we can save, and we are going to basically, how is it actually gonna work? Like, let me maybe explain that a little bit. So the player will run along, and it has an X and Y position. And we want the generator, the enemy generator, to generate enemies only on the right side of the player, right? So when the player reaches a certain X position, we want to trigger the generation of a new enemy at the position that is X plus something, like basically somewhere here. And afterwards, yeah, or maybe it's more in the future. I don't know. So, but this is basically the principle. We're running along, and when we reach a certain endpoint, like let's say this is the X position we want to reach, and when we reach it, we trigger the script and we want to generate the enemy. For this, we need to have a signal inside our player. Let's go ahead and see, open the player GD script, and let's see if there is a signal. Okay, there is already the player location because we're using that for our level generator. And we're actually gonna use the same thing for our enemy generator. So go to the world, and we are going to add the enemy generator scene here. Like you can just drag and drop it on the player, or I guess above player, like here, because we want the robot and the enemy generator to be roughly at the same layer behind the player. So when we have it here, we can now actually click on our player and go to node where we connected previously the player location. So we would like to connect the player location again, but this time to the enemy generator, because this is what we're gonna use there. So let's click connect, right click, connect, and then you can just double click the enemy generator, and it's just gonna add the default name. It's on player location. I guess not the best name, but who cares, right? So, and here we're gonna use a variable called last x. The last x is gonna be of type, I guess, integer or float, but it's gonna check basically the last location where we created the robot. So for now, we have this, and now we want to actually have a function to actually generate the robot. So let me, before I implement the full function, like the full logic, let me just add this function and try to add one robot manually and see how it works. So I'm gonna go ahead and code like generate and create a function called generate robot. And it's gonna have an X, Y position and a size modifier. For now, we're gonna ignore this, but we're gonna implement it later on in this episode, hopefully, if we have time. So we're gonna get a robot. If you remember correctly, with the preload, you can just use the class, like the preloaded class.instance, to create an instance of this scene. Like right now, this is an instance of the robot scene. And with the instance of the robot scene, we can set its position. Position X equals X. Position Y equals Y, and who knows why. Oh, that was lame. That was lame. Okay, so robot, we can implement something called set size, and then use the size modifier. But for now, I'm gonna press Control K and comment it out, or just type in this line here. And we're gonna do add child robot. So we are adding this robot as a child to the node 2D, like the root node of our enemy generator. So it's gonna be like that, basically, or like that. Okay, so let's go back, add child, and then we can say, okay, last x equals x, because this is the last x position of where we added the robot. Like we can also rename it to last added robot X. I don't know if that makes things better, but it makes them longer, and sometimes longer is better. Okay, not always, guys. Return robot. So right now, if I code this, just, I don't know, let's say 300, and let's say 0, and let's say whatever number, because I don't use it yet. And of course, I need to remove the pass before, otherwise I'll never go to this function. If I save it, theoretically, this is going to be code when the enemy generator is added to the scene, and this is calling itself the generate robot. So we're going to have a one single call to this function with 300 for X and 0 for Y. So this means if this works correctly, we'll have two robots. Yep. One of them is our manually added robot, and one of them is our generated robot. So before we actually move forward, I would like to implement the size so that we can differentiate between which robot is which, right? This I'm going to do in our robot class. So let me comment out this first. Like, I'm gonna go ahead and have a function called set size, and it will accept a single modifier, which is gonna be in the range of 0.5 till 2. So let's say I'm gonna use 0.5 to make it smaller at first. Like this, I'm going to implement in my robot GD script. So let me add a function, set size, and add a parameter size modifier. This thing is going to just set a size self size modifier equals size modifier. Like, if you remember, self means that this is accessing like the variables of this object, and in this case size modifier is the parameter. I can just rename this to value, and then it's the same. And even I can remove the self here because there is no conflict in the naming, right? There is no conflict. But of course it now is complaining because I don't have a variable called size modifier. And I'm gonna have a variable here declared, and it's gonna be 1 by default, but maybe 1.0 because it's actually a floating point variable. So why I'm only setting the variable here and not really resizing it, right? Because if I resize it here at this place, the robot is not added to the scene yet. So I need to resize actually after the robot is added to the scene. So I'm gonna go ahead and create another function called resize. And this function resize is going to take the size modifier and apply it. So we already have it set here. And what we need to resize actually in the robot, like if I go to the 2D, I need to resize the animated sprite and the collision shape. Basically, those are the two things I need to resize, the ones that I actually already modified here. So I can do that by just typing in like collision shape dot scale. They have a scale function, or yeah, scales the value, basically scales the object. Scale.x equals, I'm going to use the current scale times the size modifier. So if it is 10 pixels wide, this is the position. If it's 10 pixels wide, then it will apply the size modifier to 0.5 that we're using right now, and it will make it 5 pixels wide. So this is what it's doing. I'm going to do exactly the same thing for the Y position, for the Y property. And again, I'm copying and pasting it, and I'm going to do the same thing for the animated sprite. I like copying and pasting sometimes because it saves you time. So we have the collision shape and we have the animated sprite. what we don't have is a code to the resize. If you remember, let me go ahead and explain it once more. Like we set the size here, and then we are adding it to the scene. Even if we do it like that, we have no guarantees that this is gonna like resize it at the correct time. Like we can do like robot.resize, but probably it's not gonna work. I can actually test it, oh, actually it worked. Oh well, what do you know? But I will still prefer not to do it like that, because I'm not 100% sure that at the time after this child is added to the scene, that it is actually initialized. So I'm just gonna go ahead and go to the robot, and in the ready function, at the end of the ready function, I'm gonna do resize. I have a default value here for the size modifier, so even if nobody calls the set size, it is still gonna work. And if somebody calls the set size before we are adding it to the scene, then it's gonna resize it. So this should also work. Yeah, you see our tiny robot here, that's our generated robot. Awesome. I'm gonna get rid of those zeros here. I think they were in the robot somewhere. Let me see, velocity. Oh yeah, X here. Okay. So far so good. We have the resize function and the set size. Let's go back to our enemy generator. Okay, so we code it once manually, and I guess this is fine, right? But we don't want to have a standard size. So I'm gonna go ahead and create another function called get random size. And this is gonna return a floating point value. This is implicit, so I don't have to define it, but I wrote it just to make sure you get different feelings of the Godot engine, how you can use it and what's allowed and whatnot. Okay, so it's gonna just return a simple random value. If you remember our favorite function, run range, which is gonna be from 0.5 to 2, right? So this is what we're gonna do. And here, I'm gonna just replace the 0.5 with get run size. And if I run it again, it may be bigger. Yep, see, they are colliding with each other. Let me kill them. Bam, bam. All right. So now that we have our random sized robots, we can actually start implementing a real, a real level generator. So this is where this signal comes in that we connected. Like we can say if last x is less than player x, like if the last spot where we generated a robot is on the left side of our current player location, this is what this means, then we're gonna generate a robot, right? Where are we gonna generate the robot? Like let's say we need offset x. This is how far on the right side we're gonna generate the next robot, and this is gonna be basically random range, range 300 to 1500. So minimum 300 and maximum 1500 pixels. So this is the offset x. We're gonna also define offset y. And this is actually going to be a constant, why not? Like let's have like offset y of 300. And then let me generate the robot. We already have our function, and we can say the next x of the robot is going to be player.x plus offset x, and the next y of the robot, like the y coordinate, is going to be player.y plus offset y. And of course, we're going to reuse our get random size function. And why is it complaining? The identifier last x isn't declared in the current scope. Okay, I renamed it to this amazing name, last added robot X. Player isn't declared in the yeah, because when you actually create when you connect the signal, it created this function manually, right? But if you remember, we are adding two properties like the player X and the player Y position. So we basically have to declare them here, right? So we don't have player actually. We have player X, player Y. So I'm gonna replace this player.x because of course we don't have the player here itself. I mean, we can do pass it, but we don't need it, right? We just need the X and Y position, and that's what already our previously declared signal has. So let me try it. All right, now I have two robots, but if everything works correctly, I will have more robots as I run along, right? In different sizes as well. Like, yep, there is one, there is one. I can even make it super crazy and say the random range is from 100 to 200 or 300. Then I'm gonna have a lot more robots. Yeah, it's raining robots. And I am somehow I killed it. I don't know how. That's when you let the robots drop on your head. Like how most of them are just on my head, dropping. Yep, but you get the idea, right? Yeah, I'm the robot slayer. So far, the robots don't kill me, but that's also gonna come to a point. Anyhow, so let's keep it like that. And I think this is all for this episode, guys. So if you did like it, please give me a thumbs up. That helps me tremendously. And also subscribe if you haven't, if you're interested in seeing the full series. I mean, you can still see it. Anyhow, so thank you very much, guys, for watching. Thank you very much for all your nice comments that I've been receiving in the past days. So this really is awesome, and you're awesome as well. So you better know it, as I keep telling you every episode, but still, just in case you forgot, you're awesome. That's it. All right, guys, so have a nice day, have a nice evening, have a nice morning, or whatever you're having. It should be nice. Bye bye.